Okay, I'm hoping final video. Here we go. I'm going to make a brand new class. It's going to be the linked list node child class, the doubly linked list node class. So let's have a quick right click. I think I should be able to do this. No, I have to do on the folder itself. Add class, and I'm going to be all original DLLNode. Oh, what an original name. Okay, and that's from the base class LLNode. Go figure. And it's public. We're not changing this at all. At the entire term, we're not changing that. Fine. So let's just create it and see what we get. Okay, same as last time. I actually already made this file. I've deleted it since then, but here is what I'm getting for free. And I can just compile it and it should work. In fact, DLLNode.h is going to include LLNode.h. I'm going to go to doublylinkedlist.cpp. I'm going to include doublylinkedlist.h. I'm going to include my brand new file. I commented it out. doublylinkedlistnode.h. Great. And then doublylinkedlistnode.cpp can technically, it doesn't even need to include doublylinkedlist.h. It can include, which is the default that it does, it could include dLinkedList.h. Let's see if it compiles. Come on, come on, come on. Hopefully you're working. Notice it goes much, much slower if I change my header file. That's why we have header files, so that one thing is stable. The CPP files you don't have to rebuild everything all over again for the CPP when you change your CPP file. You do when you change your header file. Okay. I'm going to actually change this class, but I actually need to look at what LLNode.cpp has. Or at least I can look at let me look at the header file. That's probably better. Okay, so what do I have in here? I have some private data. I'm going to change that. I need one new pointer. I need the previous. I have the data, the thing that's being stored. I have the next, and I want the previous for a doubly linked list. I have some kind of constructor. I'm going to ignore destructors for it. I don't need one. I never call new. If I don't call new or nothing gets created and I don't need to do any kind of cleanup at the end, I don't need a destructor. So I'm going to leave off the destructor at least. Print node. Do I need to change that? Nah, I'm going to leave it alone. Get next. Do I need to change it? Nah, leave it alone. Right? Getting the next element has not changed from this doubly linked list class compared to the old one. It's the same. I have a next pointer. I go to the next one. Nothing has changed. I just added a little bit more information. I got the previous. Right? It's like getting a new phone, right? Your old phone, it does the same thing as your old phone and it has a couple extra features. Well, that's hoping, before they start changing your phone around, they remove the home button. Okay, is at the end. Don't want to change it, right? It's the same thing. Am I at the end? Well, is there another node after is the next pointer null? That tells me if I'm at the end. Set the next pointer. No, that doesn't change. Get the data. That doesn't change. In fact, none of this is going to change at all. I got to change one thing. I got to add the constructor. I got to be able to set the previous, get the previous. Yeah, that's it. That's it. That's the whole thing. So let's have a look at this one little thing. Double linked list node.h. I'm going to plop that in there. It's a doubly linked list node. No real changes there. And then what else do I want? I want void. Okay, in all these cases, by the way, if you hadn't noticed, I'm going to do public. I'm going to try and figure this out. This is actually one of the big bugs I had in the original version of this I recorded like a year ago or whatever the case was. This is where the big screw up was. I accidentally forgot to type the word public in there, and I got a weird error. You can look at it if you want in the original video. You got a weird error because it says these functions weren't defined, and I look around, I can't find that function. And it's because it was protected. By default, it's protected. So you want to be explicit. Okay. set previous. Okay, and I'm going to have, what do I want? I want to set the previous, and so I will do, oh, that should probably, let me look at my linked list node dot, where is it now? .h. The previous and the next. Get the next, get the previous. It needs to know, okay, that's still fine, because the linked list needs to know about it. Okay, set previous, linked list node, new previous. All right, and okay, and then I have another little point to bring up. We're going to get to that point. Actually, let me do this. First of all, spelling, fine. That should have fixed its wagon. There you go. Private, and then I want to have previous. Okay. And now you hopefully might see something like, what's something weird about this? What's weird about it? Well, if I have a doubly linked list and I have each of those nodes are DLL nodes, doubly linked list nodes, they have a previous and a next. I actually want to make sure that they're all doubly linked list nodes, not just some. Every node I put in this thing, I expect it to be a doubly linked list node. So set previous, I don't actually want it to be the LLNode. I want it to be a doubly linked list node. I want to be explicit. If you try and stick a normal linked list node that's not a doubly linked list node on this thing, I want it to yell at you. I want to know when I'm doing something wrong right away. Same thing here. If I want to get the previous, I'm going to return a doubly linked list node. Otherwise, I know for all doubly linked lists, it only has doubly linked list nodes. So this thing is also going to be doubly linked list node. Fine. Oh, I hate some of the pop-ups that we're getting here. Sorry, folks, if it's flickering. Okay. So here's what we have. I have my lazy sprag special. That's going to be a thing, isn't it? Like calling it the lazy sprag special. You'll be interviewing at some company. Well, I'm going to do a lazy sprag special here. Okay. Okay. My data is going to be set. I'm going to be doing the parents version of something first, right? We'll get to that. And there I have one new variable, p previous, and that is going to be null. I want I want to have safe starting values. And again, by the way, you would notice that, or you should notice that I would really have a whole lot of comments everywhere if I was not trying to live code this thing, right? Great code should have comments to explain what's going on. If I want to set the previous, I want to say p previous is equal to p new previous. Great. I could make it so that I can't set the previous anymore under certain conditions, let's say. That's one of the reasons we have setter functions. It allows sort of advocacy on the part of the node itself or the object itself. The object says, no, that's bad data. I can't take that. Okay. So maybe I can error check the new node coming in. All right. And this thing is going to be, I'm going to get the previous, right? So return p previous. All right. And that should do it. I have one little problem though. There's still an error here. The error is there for a reason. It says no default constructor exists for LLNode. The reason is because LLNode only has a constructor that takes in this right here. Looks exactly the same as here. I don't have a default constructor. I need to explicitly state what constructor I'm using. So let's do that. What constructor am I going to use? I'm going to use LLNode, and it's the constructor with D in it. I'm using this constructor, the linked list node constructor that takes in some LL data. that constructor, not another constructor, that one in particular. I can choose which constructor I call. So when I have a DLLNode, I can call the correct LLNode constructor that I want, because I always call the parent's constructor. For set previous, set get previous, all these kinds of stuff, I don't automatically get the call to the parent's version of the class, of the parent's version of the function. So I don't, this is the one time I need to do this. I say exactly with a colon and then which constructor I want, the exact constructor I want. Okay. That will make no difference to my code at all. Why? Because I'm not using DLLNode everywhere. I should be, but I'm not doing it right now. Let's go to DLLlist.cp, actually DLLlist.h. Okay. When I make a DLL list, when I insert a node or remove it, that's all fine. Here we go. It should be a DLL node. When I set the endpoint, it should always be a DLL node. I can't put anything else in there. And the actual endpoint should be a DLL node. Right? The only thing I'm allowing this in this linked list is a DLL node, a doubly linked list node. The node's custom made for my doubly linked list. Okay. Well, I'm gonna have to fix this because I'm getting these green lines, right? It's saying this hasn't been defined yet, or it's not found, right? Because it's actually in here. If I go down here, look at. There's gonna be a whole bunch of green everywhere, and you'll also see weird things like this. Oh wait, when I make a doubly linked list, I want to actually only put in doubly linked list nodes, and this is a reason why I change this insert up front, because I want to make my new node, it's a doubly linked list node. Every single time I make a new node to stick into this linked list, it better darn well be a doubly linked list node. So let's plop one in here. Now notice, inserting at the front, I'm inserting this at the front. At the front here, I am inserting a doubly linked list. This happens to be a doubly linked list node. It's a kind of linked list node, so it's perfectly okay to be in there. It's also a pointer, but I'm allowed to insert a doubly linked list node. Everywhere I say it's a linked list node, I'm allowed to put in a doubly linked list node. So it's more specific. It's saying, I need to watch an action movie tonight. I'm watching Die Hard. Well, that's an action movie. It counts. Now, I need to watch Die Hard tonight. It's not the same as I want to watch an action movie. It can't go the other way. One's more specific. The child class is more specific than the parent class, always. Right? The parent class, everything in the child class is in the parent class, and it's just a little bit more specific. Okay. So everything that's in the child class is also a type of the parent class, but not the other way around. I don't know why I was thinking about Die Hard, but I'm never not thinking about Die Hard. It's a great movie. Okay, so here we go. I'm going to, if I'm inserting at the front, I make a doubly linked list node and I insert it there. Great. If I'm inserting at the back, I make a doubly linked list node. I'm inserting at the front if it was empty beforehand. Fine. And I set my pend. Otherwise my former end, I now set the next one to be the new node. I'm going to have, here's my to-do. And I happen to know that this is set prev. Oh, we're going to have one problem. It's going to yell at us for something. It won't yell at us because we're using a doubly linked list node. Okay, that's fine. We're going to see a casting here sometime soon, so I just wanted to warn you in advance. Oh, and I need to get rid of the to-do. Okay. Remove from the front. Okay, so I remove the node and make sure, so I call remove from front from the parent class. And then if it's empty, I set the pend to null. Okay, that all works. Nothing's changed in that. How about this one, remove from the back. I have a to-do in there. So what do I, so this right here, I am removing from the, I'm calling the parent version of remove from back. I'm not sure I want to do that. I think I'm going to actually have to change this function around. Why? Because I know where the back is already. I don't want to have to go remove from back for linked list. I guarantee it has to walk all the way down my linked list, find the last element, remove it. What I want to do is just say, like, you see where p-end is, go there, remove that, done. Okay, so if I'm doing that, I need to get the previous. But I can get the previous. I can, as long as it's a doubly linked list node, I'm fine. I can just ask for the previous. Okay, so we're gonna have to change this thing. I'm gonna just comment it out for now. But this is gonna be pretty overhauled. Okay, so what do I do to remove from the back? I'm gonna have if p-end does not equal null. To be more explicit, I often will just write if p-end for if it's not null. But if it's not equal to null, then what do I want? I want a DLLNode p previous node, and that's going to be equal to p and get previous. Okay, so if I have that, then that's going to be my new endpoint, this p previous node. If this was not equal to null, that's p previous is now my new endpoint. Whether it's null or not doesn't matter. Even if there's one element there, get the previous is, I will have to do one other check in here. But if p previous node does not equal null, I have to set that to whatever, to null. So so set the next of that to be null. Set next. All right, 1. I set the next to be the previous, so for the previous nodes, I'm going to set the next to be null. As in, I'm just making it the new end of my doubly linked list. I'm going to just remove the previous node. Oh, I also want to do something else here. And I'm going to check to see my other remove from front, remove from back, because my p-end, if there is a p-end here, I want to delete it. So, all right. What other things do I need to do? If the thing is empty, and my wife is coming in here, so I'm hoping she's not going to be talking to me here. If I'm at the end of my my end of my list has a null in it, then I have nothing in my list. If that's in fact the case, I'm just going to return false. I didn't remove anything. It didn't change anything. Okay. I can't believe this. This is the 3rd time implementing this class, and I have not had to cast yet, which is freaking me out a little bit. Get the end. Okay, that should work. That's really weird for me right now. Well, we'll see. Let's compile it first. Okay, double linked list node, get the end. I'm going to return this. Why is this? Maybe I'm missing a closing parentheses or something. Let's have a look. Oh, get end. Let's go back to get end. Double linked list h. Okay, get end. That's the same as it was in linked list.h. My generic linked list also had get end. So I don't want it to be a doubly linked list. I want it to be a linked list just so it looks the same. Looks the same as the parent class in this class. Okay. Double linked list.cpp. All right. So p-end is a doubly linked list, but it's also a doubly linked list node. It's also a linked list node. So you're fine. This one I need to change. This one, doubly linked list node. This is the new end, and I set it. And hopefully, okay, let's see what happens with my code. Maybe it does work. Last time I ran it, hit an assertion error. There we go. Great. What? Why is that great? Because I want to find my errors as soon as I can. Here we go. Here's my error. The size is calling get next. Wait, where is it calling next? When I'm printing out everything. Okay, when I'm printing out everything. After I've removed all my nodes, so I have an empty array, and then I have this. What could be happening? So I've removed all my nodes. I go to print it. I insert. It's actually in this print statement, right? Yeah, it's in this print statement. When I have an empty linked list. So what do I know? It means that my let's look at my code again. I have a hunch about this, but we could always look at this. And let's actually do this as an exercise, because I had the same problem yesterday. Honest to God, exact same problem. So I know what the error is, but let's have a look. I'm putting a breakpoint down. I want to show you this in action. I press play. I get to my breakpoint. I go into my function. So it's the step into it's F11. Okay, I'm going to go down into print. I'm going to get the error right here in is empty. Why is it giving me an error in is empty? Let's look at start. And p start is CCCC. It's not null. It's CCCCCCCCC. Why is that? And it only happens when my linked list is empty. Not at first, but when I've cleared out my entire linked list, that's when I get it. And so my hunch is it's something to do with p start, because the data looks really weird, and it's something to do with deleting. And since the thing that I did the most work in is in deleting stuff, I can go back to linkedlist.cpp and I can look at what I did here. And presumably, so the parents version of it I call remove from front, and that hopefully would work out the way you'd expect. Here, however, if this is equal to not equal to null, what do I say? Okay, so if p end is not equal to null, then it means I have one or more nodes. If p previous is not equal to null, then I have a previous node. What about the other case? So this would be me walking through this code. I'd actually put a breakpoint for when this gets called just before that last printout, because I know that that's sort of where this is happening. And I'd walk through it. And I know it's something to do with p start. And I'm trying to piece this together, and I'm looking at this and going, when does p start's going to go wrong when I'm removing the very last element? So not in this condition, the other condition, the else condition from this. What's the else condition for this? If there's no previous node, then this is the one node that I had, and I'm removing it. So p start has to be null as well, and I haven't been setting I didn't set p start. So what do I want to do here? Because I'm not calling the parents version of the class. So p start, I need to set a p. I don't have access to p start, so I can try it, but it won't work. Is equal to null. Should yell at me. There it goes. It yells at me, right? Because p start, I don't have access to it. It's private, so I need to set start. That should set start ptr. I'm setting the starting point to null, which means it's when I go to get the size, when I do that printout, and I go to get the size, it's going to say the size is 0. And therefore, I don't get that error. That's what I'm hoping. I'm hoping I'm going to check my code. I'm not going to just assume it's going to work. I'm going to check it. Okay. I'm going to take one step forward. Hey, it printed out. Okay. Let's just continue on here. I emptied it. I added 2 nodes. I removed 1 node. I called the destructor. I called the destructor. Hey, that actually worked. That worked nicely. I wanted to check one more thing before I stop and hope for the best when it comes to the video quality here. I need to look at, I looked at WLinklistNode.cpp and I said, whoa, I need to call delete. I want to make sure I'm still calling delete, even if I'm removing from the front. Removing from the back, I also have to call delete as well, but I'm calling it in one of my functions. So let's have a look at, or I don't even know if this has been fixed. So get index. I want to double check my work a little bit, or a lot. Remove from back. Okay, I am calling delete, at least in this case. And otherwise, I'm calling delete. Okay, thing to delete, that's fine. And remove from front, I'm calling delete. All right, I'm good. I just wanted to double check. Okay, so what did we do here? We made 2 brand new classes that were child classes of our linked list class and our linked list node class. We hooked everything up. I did a little bit of code. I checked it, made sure it worked. I could even do more tests, and I'd definitely be putting in comments if I had a bit more time. I don't want to take all the time in the video. But what I want to do is just incrementally work on my code, and I'm thinking through it every step of the way. I'm hoping this demonstrates why we use inheritance. Because my doubly linked list node class, this thing here, let's look at it. Yeah, there it is. That's the entirety of it. It's hardly anything. It's 17 lines. And barely that. Half of those lines are curly braces and blank spaces. Like, there's nothing here. Because most of the work is being done in the parent class. That's what I want. I don't want to be replicating my code. So by being very strategic about how I choose a child class and how I only change the stuff that's different from the parent to the child. And that's what we're trying to demonstrate here. Okay, hopefully that video worked this time, despite all the horrible lighting and everything, and hopefully this made sense. So please ask questions if something doesn't make sense. Inheritance is, once you get it, it's wonderful and it's so obvious, but until you do, it can be hard for some people. So just make sure that if you're not quite sure, work it through, talk it through, whatever works for you. You just need to make sure you understand why we do it. It's so we don't replicate our code, so that we make sure the code is actually working, and then we can take advantage of what a parent class does. It gives us other advantages as well, because every one of our linked list nodes, whether it's a double linked list node or a linked list node, they're both linked list nodes. And I can do stuff with that when I hit polymorphism next. All right, thank you everyone, and hopefully you had a great night. This is my wonderful Saturday night, so good times. All right, thanks, bye.